All right, let's dive in. Today, we're talking about a huge, behind-the-scenes battle to make websites just work perfectly, everywhere, for everyone. It's a crazy story, really. It's got chaos, bitter rivalries, and now, finally, a bit of cooperation. I mean, you know the feeling, right? You pull up a website on your laptop, it looks awesome. Then you open that same site on your phone, and it's a complete disaster. A total broken mess of text and images. Well, that frustration, that is exactly what we're going to unpack today. So here's the game plan. First, we'll define what this universal problem really is. Then we'll do a little time travel to see how we got here. After that, we'll check out the modern cloud tools developers use to fight back, pit two of the biggest ones against each other, and finally, explore a new approach that might just fix this whole mess for good. Okay, let's kick things off. What is the fundamental reason a website can look so perfect in one place and so bad in another? Well, the industry has a name for this headache: cross-browser testing. And it's pretty much what it sounds like. It's the whole process of making sure a website works exactly the way it's supposed to, whether you're on Chrome, Safari, or Firefox, on a laptop, a tablet, or phone. The goal is simple: a perfectly consistent experience for you, the user. And you know what? This is not a new problem. Not at all. Its roots go way back to the very beginning of the web. Okay, picture this. In the early days, it was the Wild West. Every browser interpreted the same website code in its own unique way. It was total chaos. So, as a sort of peace treaty, developers started putting this one simple line of code at the very top of every page. It was a message to the browser that said, hey, stop making up your own rules. Follow the shared rules. That's called standards mode. The alternative was quirks mode, which was, well, just as unpredictable as it sounds. But the problem just kept getting bigger and bigger. The famous browser wars of the 2000s were just the start. Then the smartphone arrived. And that just blew the whole thing wide open. Suddenly, it wasn't just a few browsers. It was thousands of different screen sizes and operating systems. And by 2016, it was official. Just as many people were using the web on their phones as on their desktops. This huge, complicated mess was here to stay. So, if there are literally thousands of possible device and browser combinations out there, how on earth does anyone manage this today? I mean, you can't just go out and buy every single phone on the market, right? The answer, like with so many things, is in the cloud. Modern developers use these incredible platforms that are basically giant remote device labs. They can log in from their desk and instantly test their site on a real Google Pixel, a specific version of Safari on an iPhone, or even an old version of Internet Explorer, all without ever touching a physical device. And these platforms are a lifesaver because finding and fixing just one bug is such a grind. You have to find it, then figure out how to make it happen again reliably. Then you have to hunt down the exact line of code causing it, fix it, and then test everything all over again to make sure you didn't just break something else. These cloud platforms are designed to make that whole painful cycle way faster. And of course, a problem this big created a huge market for testing tools. So let's zoom in on two of the biggest players in this space, BrowserStack and Lambda Test, to see how they tackle the problem. At a high level, you can think of it like this. BrowserStack is the established champion. It's mature, and its claim to fame is a massive collection of real, physical devices you can test on. Then you have Lambda Test, the fast-growing challenger. Their whole game is about speed, scale, and giving you more bang for your buck. And when you dig in, you can really see their different philosophies. BrowserStack goes for depth, offering the most real devices and top-tier security, perfect for big, established companies. Lambda Test, meanwhile, is built for pure velocity. It lets teams run a huge number of tests all at once, which makes it a really cost-effective choice for fast-moving startups. So you'd probably choose BrowserStack when having access to the absolute widest range of real devices is your number one priority. This is especially true if you're in a regulated industry like finance or healthcare, where their heavy-duty security certifications are a must-have. On the other hand, you would lean toward Lambda Test if your main goals are speed and efficiency. If you need to run hundreds or even thousands of tests all at the same time and want to do it without breaking the bank, Lambda Test becomes a really compelling choice. But here's a thought. All these tools are reactive. They help you fix problems after the code is already written. What if we could solve the problem at the source and prevent the bugs from ever even happening? And that right there is a huge paradigm shift. For decades, the model has been a developer writes code, then tests it to see what's broken. The new approach is proactive. Get all the big browser makers to agree on how a feature should work before it's ever released to the public. This effort is called interop, and it is a huge deal. For the first time, you have these fierce competitors, we're talking Google, Apple, Microsoft, and Mozilla, all actively working together. Their goal is to make sure new web features work the same way in every browser right from day one. And this cooperation unlocks some incredibly powerful and creative tools for developers. Imagine complex animations that are perfectly tied to your scrolling, or seamless app-like transitions between web pages. Things like these used to be a nightmare to build consistently, but now they're being designed to work identically everywhere, from the get-go. To make this all official, they've created a new status called baseline. You can think of it like a stamp of approval. When a feature achieves baseline status, it's a clear green light to all developers that it's now fully supported across all the major browsers and is considered safe to use in their projects. And this isn't just some vague promise. There's a concrete rule. For a feature to be considered baseline, it has to have been stable and supported by all the major browsers for at least 30 months straight. This completely replaces all the old guesswork with a real, predictable timeline for developers. Which brings us to our final question. We've gone from the complete chaos of the browser wars to a future of proactive collaboration. As browsers finally start to agree on the rules and speak the same language, are we actually witnessing the end of the broken web as we know it? It's a fascinating thought.